All right, 21. So we had cosine squared of x, tangent squared of x, tangent squared of negative x, minus 1 over cosine squared of x. So the tangent squared of negative x, what does the tangent of negative x equal?
Negative tangent squared x.
Okay, so this would be, let me just do this off to the side over here. So the tangent of negative x, that whole thing is being squared because that's equivalent to what's written here. So then this would be negative tangent of x squared. So when you square that, the negative sign's going away. Tracking? Okay. So this is going to become cosine squared of x, tangent squared of x, minus 1 over cosine squared of x. So now I can rewrite tangent as sine over cosine. So it'll be cosine squared x times sine squared x over cosine squared x minus 1 over cosine squared x. So cosine cancels. So I'm left with sine squared x minus 1 over cosine squared x. Now what? Any ideas? That's fine. There's other ways you can do it too.
Should I change tan squared negative x minus 1 to sine x? Or sine squared x plus cosine x?
I have a question. So, say you.
Hold on. How did you get there? Because this stuff's being multiplied, so.
Well, I just changed negative 1 into sine squared x and cosine squared x.
Oh, you rewrote the negative. Okay, I got what you're saying. Okay, what was your question?
So, is it. What's it called? I forgot what it's called. It was if A equals B, then B equals A. Is that the same theory applied here or no? So, if it's secant theta equals 1 over cos theta, if it's 1 over cos theta is equal to secant.
Okay, look, I'm gonna explain this because it's driving me insane. SIN is sine, COS is cosine, TAN is tangent. Okay, so when you're saying it, it's not cos, it's not sin. Okay, it's sine, cosine, tangent, secant, cosecant, cotangent. Okay, cool. Okay, thanks. Try again.
1 over cosine theta, would that be equal to secant theta, or would it just be secant theta equals 1 over cosine theta? It can't be vice versa.
Those are the exact same thing.
So
An equal sign means that they're equal, no matter which way you say it. What does the top kind of look like? I'm not saying it is, but what does it kind of look like? Okay, it kind of looks like a Pythagorean identity. It kind of looks like sine squared plus cosine squared equals 1, right? Now, obviously, I've got sine squared of x minus 1. So basically, I'm dealing with something that looks kind of like this. Okay, now, obviously, that sign is flipped. But, mathematically, I could pull a negative sign out of the top. Okay, So if I do that, if I remove a negative from here, I would be left with negative sine squared plus 1 over cosine squared x. Now I have this, which is just this written a different way, right? I can change the terms and they're still the same thing. Okay, so this looks like this. So now this is equal to cosine squared, but I have this negative that I took out. So negative cosine squared x over cosine squared x is equal to negative 1. Now, if you got there a different way by properties that still are equivalent, like that are true properties, then that's fine too. Sometimes I say that because sometimes people start making up things to just try to get to what they think the answer is supposed to be, and they're not like true properties. So I will check that with these types of problems to make sure that you're using properties that are actually legit and not just making stuff up, because you know what the answer is supposed to be. All right, any other questions about the ones you had yesterday for homework? If not, I'm moving on to verifying, which shouldn't take that long. It's only a few problems. All right, for verifying problems. You may only manipulate one side. So in all of these problems, you're going to be manipulating the left, leaving the right alone. So leave the right side alone. So in this one, they give us the end goal. We have to show how to get there using properties. Okay. Now, again, there can be multiple ways to get there, but I'm going to check and make sure you use true properties, like trig properties, to get there, or just like mathematical properties in general. Can't just be like, oh, I know it's supposed to be -1, so I'm just going to all of a sudden do something and poof, it equals -1. It cracks me up when there's like a whole bunch of middle steps that make no sense or aren't mathematically correct, because you just know what the end goal is supposed to be and you just go straight there. And every year I have people that do that because they don't believe that I'm going to check, but I do. So, just warning you now. All right, 26. Tangent of theta, cosecant of theta, cosine of theta is equal to 1. So what I do when I start these problems, because I know I can't touch the right side, is I just draw a giant arrow going down. So that I know, don't do anything to that side, I'm only going to work on the left. Now obviously some of these are only going to have 1 or 2 steps and my arrow is going to be too long, but that's fine. Just for the sake of knowing, don't touch it. So I'm still looking for what things can I rewrite over here on the left in terms of something else. So like, how could I rewrite tangent? Yep, sine theta over cosine theta. How can I rewrite cosecant? 1 over sine theta. And then I've got times cosine theta. So now I can go through, sine on top and bottom cancel, cosine bottom and top cancel. So I get 1 is equal to 1, and I have verified it.
Can some of these not be verified?
No, they all can. They're telling you they're equal, you're just showing how they got there, basically. Or why it's that. It says it's like a proof without stating the reasons. Basically. Alright, 28. Sine of pi over 2 minus x times tangent of x equals sine of x. What's something I could rewrite here?
Rewrite the sine pi over 2 negative x cosine.
Cosine x. And then can I rewrite tangent? Times sine of theta, or sine of x in this case, over cosine of x. And like I said it yesterday, but if you swap them to thetas because you prefer thetas, or if you swap them all to x's, that's fine as long as you're consistent throughout the problem. Don't like jump back and forth between the two things. So cosines cancel. So sine x equals sine x. And it's verified. Let's see. 30. 2 minus cosine squared theta is equal to 1 plus sine squared theta. Any ideas on this one? It's a little harder.
Wait,
I see squared things, so what am I thinking right off the bat? Pythagorean identity.
can we add the cosine?
Nope, I can't touch the right side. Would you agree that 2 is equal to 1 plus 1? If I write it like that, do you know what to do now? What's 1 minus cosine squared theta? You might have to manipulate one of your identities to be able to do it. But what is 1 minus cosine squared theta?
Use sine.
Sine.
Yep, so sine squared plus cosine squared equals 1. So sine squared would be equal to 1 minus cosine squared. So now I'm left with 1 plus sine squared theta, which is equal to what I had over here. And it's verified. Alright, gonna get a little harder again. 32. Sine squared of negative x over tangent squared of x is equal to cosine squared of x.
Change the tan to sin over cos.
Sine squared x over cosine squared x.
And then negative square x on top.
So the negative comes out, but remember that squared means it's on the whole thing.
So
This is a fraction.
And you do the keep change flip.
Keep, change, flip, and when I square, this negative sign's going to go away, so I'm going to write it as sine squared of x times cosine squared x over sine squared x. Now what?
Do you cross the signs out?
And I'm left with cosine squared x equals cosine squared x. Alright, try this last one on your own, and then we'll go over it, and then we'll be done, because this is a much harder one. See if you can do it. 34.
I did not do my backpack.
What'd you say?
I did not bring my backpack.
To school, or just like to
I
class?
think I just didn't bring the class. I don't know how.
Sine of x over 1 minus cosine of negative x is equal to cosecant of x plus cotangent of x.
Oh gosh.
You can't touch the right side, right?
Correct. I'm going to give you a hint. You're going to need a conjugate. So like when we did like the stuff with i's, we would do like 1 plus I times 1 minus I. That's a conjugate. So like in this case, you have, well here, let me get you to this part and then I'll let you continue. So I've got sine of x over 1 minus cosine x, because cosine of minus x is just cosine of x. So I'm going to need to multiply top and bottom by 1 plus cosine of x.
You can do that?
Yes, because I'm multiplying by 1.
What?
So now see if you can get there.
Just like, do whatever you want.
Well, I multiplied by 1.
This is making me more confused.
I got it.
My advice is going to be don't actually multiply the top through yet. Leave it like it is. but I don't know what it is.
I think it was wrong, but that's Pastor Dawn gave us.
It better not be. It will be mine if it is. I low-key forgot mine squeaked one day, so I like picked it up, and I just like, out of habit, just like squished it, and I was like, oh goodness. I was like, nope, not doing that. Laid it back down. So if you left the top alone, what do you get on the bottom when you do this?
Sine squared
Science.
x plus 1.
So it would be 1 minus cosine squared x, which then is sine squared of x, yes. So then I have sine of x times 1 plus cosine of x over sine squared of x. Did we get there?
Wait,
No.
say that again? Say that again?
So, I was like, what just happened? So, here, so I went to here. So then the bottom is sine squared of x. So I have sine of x times 1 plus cosine x on the top over sine squared on the bottom.
I didn't know what to do that.
So then sine cancels and the square of the one on the bottom cancels because I'm still left with 1. So I just cancel out the little square. So then I'm left with 1 plus cosine x over sine of x. Then what can I do?
You, one.
Just do the same.
Because think about what I'm trying to get to. I'm trying to get to cosecant of x plus cotangent of x. So what does that mean? How many pieces am I going to need?
Cotangent of x equals
That's not what I asked. How many pieces am I going to need?
2.
2. Okay. Right now, how many do I have? 1. This is all one unit. How can I split this into 2 pieces?
Multiply by 2.
Yeah, multiple.
I've got a common denominator, right?
Yeah.
So if I've got a common denominator, that means I could split it into 2 separate pieces to give me 1 over sine of x plus cosine of x over sine of x.
That's what cosecant is.
Yep, so 1 over sine is cosecant, cosine over sine is cotangent, and then I get to the end result. Now, would I have just known to do that if I hadn't been given the end result? Maybe not, right? But I was given the end result, so I knew what I needed to get to. Okay, now that's as hard as they get.
I mean, that's what I have to do.
But these problems are the ones where I'm talking about people start giving me a whole bunch of baloney in the middle. They'll skip like 4 of those steps. Somehow they might make this last step up and then they get to this one. But this stuff in the middle is missing. Okay? The stuff in the middle has to make sense if you want all the points. Okay? I know what the end result is. I want you to show me how to get there. Okay? Now, again, this is as hard as they get. This is the hardest problem in that section. So, the more you do with them, the better off you'll be because you'll get used to the patterns and what I'm looking for and things like that. Like, I didn't get to see all this stuff the first time I ever did it, right? It took time. So, yes, what's your question?
So 1 minus cosine squared x can factor out to sine squared.
Well, so this is the Pythagorean identity that we did up here. Where is it? 1 minus cosine squared is equal to sine. Because sine squared plus cosine squared equals 1. So those Pythagorean identities, you know them, but they're written a certain way. And what you're going to find is often we need to rewrite them to be able to use them. Did I actually derive them for you in the notes?
What does that word mean?
I don't know.
Did I? Okay, so like I started you with sine squared plus cosine squared equals 1. Did I explain how to find the other two, or did I just write the other two?
Let's go.
Like, was there work that went with them, or did I just write the 3 back to back?
Yeah.
I just wrote the 3 back to back?
Yes.
Okay, well, let me show you how to do that before I give you problems then. So this happens to be problem 38, but I would show it to you anyway. So, all right, so we start with the one you just have to know is sine squared plus cosine squared equals 1. But I want to find the other two, or let's say I don't remember the other two. I only memorized one of them, and I'm like, oh no, I need all 3 because, I need to know them because I need to verify something. So if we take this entire function and we divide it by cosine of x, so I divide every piece by, or I should say cosine squared. Sine squared over cosine squared is?
Wait, I thought you can't do that with sine.
What?
Never mind.
Tangent squared.
Tangent squared. What's cosine squared over cosine squared? What's 1 over cosine squared?
Secant squared.
Secant squared. And that's your second identity.
Yeah, you did.
So then,
Okay. Oh, okay. Yeah, we have. Oh, yeah, we have that. It's just math.
and then the other one, if I divide by sine squared across,
Oh, the proving Pythagorean. Yeah.
then I get 1 plus cotangent squared equals cosecant squared. I'm going to tell you, oftentimes this is an extra credit question to prove these. So I would make sure you know how to do that if you want extra credit on quiz or test. I'm not going to say it always is, but it tends to come up at least once where I let you do that for extra credit. All right, so in addition to what I gave you yesterday, and I do have your test to give back since I failed to do that yesterday yet again. I'm going to give them back once I give you these, but 25 through 33 odd.